This is where ML is going to always surprise us. It doesn't stop innovating. It is constantly coming up with new things. So here we are, we were like, oh, finally, vision is solved. You can now take a photo and edit it. And we are on to, can we do things like crazy LLMs, which has vision and audio and some language and editing? Like, tell me what more I can pack together.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm excited to be joined by Siddhika Nevrekar. Siddhika is head of AI Hub at Qualcomm Technologies. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Siddhika, welcome to the podcast.
Thank you for having me here. Excited to talk to you.
I'm excited to speak to you as well. We're going to be digging into your work to bring on-device AI to the world and the various hardware solutions that enable this, as well as a bit of what you've learned in speaking to hundreds of developers, AI developers in particular, over the past few months. To get us there, I'd love to have you share a little bit about your background.
Sounds good. I'll start way back in the past when going a little bit back, I got my computer engineering. It's like a lot of folks in the field. And then I went on to do the MBA to just understand business aspects of how do you, build a product, build a company, and so on. And then, over the course of time, I went into Microsoft where I spent about 9 years, and that was all on ML and cloud. So my memories and learnings of AI is all based on what I learned building a search engine. And it was all about relevance and ranking and large and enormous amounts of data, ginormous models, hundreds and thousands and millions of inference queries responding to so many questions that people ask on a search engine. So it was all about that, going on to maps and navigated a lot of that.
Was this on the Bing, one of the Bing teams?
Yes, it was Bing Maps, Bing Shopping. I was very lucky, very fortunate to work on a bunch of verticals within Bing and overall ranking relevance as well. Then I took a deliberate decision of moving on to device because it was all cloud. It was all a world of services and servers. And I thought, okay, let me learn something new now and make myself extremely uncomfortable. And that's when I went to Apple, this is the device world. And I got a chance to work on ML there. Very, very fortunate again. And to be honest, Sam, I did not believe ML on device existed. Like that's not true. That was my first instinct, sort of first thought that came to mind. Because again, these are large models. You've got to have so much data to train these models, be able to host them, when the model has to understand so much more. And clearly that cannot happen on the device. The 6 years I spent at Apple, that thought completely changed because my first year was when Apple Neural Engine chip was launching. And there was this big push on what is the key feature to showcase this. It's the AI chip that goes into the device. How can we make the most of it? And that was the Face ID moment where can we have phones unlocking with face? And that's a big deal because you have to recognize the face no matter what happens, right? You change your hairstyle, you change your facial hair, so many things that get older. And the phone still has to recognize you. And working through that was the first experience. Working through that, building a platform for that made me realize that, oh, this is just the beginning. So spent 6 years working on a variety of use cases, going from detection on the watch to fall detection on the watch to cameras, which have 25 models and so on. And then left Apple, started my own company along with Krishna Sridhar. I was the founder of Tetra AI. And that's where this beginning of can we bring any model to any device started. Cut short, zoom in, got acquired by Qualcomm, moved into Qualcomm, and now built this product that we'll talk about, which is AI Hub.
Yeah, I think your 6 years at Apple and your realization that, hey, this, getting AI running on devices kind of actually calls into focus a question like, why is this still a big deal? Why do you have teams there working on this? Apple's been doing it for 6 years. We've been using AI on our devices for, several years. What are the outstanding challenges in that world?
That's a really good question. The biggest challenge for an app developer is when an app developer decides, hey, I want to put an AI experience within my app on a device, they are essentially bringing the model which was on the cloud, where all the queries could go from all of their users, from all the apps, whether it's on an Android phone, on a Windows laptop. That's easy. You have one system to manage, one system to host a model which answers all the queries. But now this app developer is saying, okay, I have to take this model and put it into application instance of every user on the device. All these devices are very, very different.
Taking a step back, why are they doing that? If they've got an application that's working in the cloud, why are they taking that next step of making them native to the device?
The purpose is very, very clear in these developers said they want to save money. That's number one. So most of the times people will start with privacy, but I'm starting a little bit different. I'm saying saving money because every time you send a query to the cloud, you're paying for that cloud infra. You're paying for hosting. You're paying for that scale. They can save all that money because really they're using the free cloud in everybody's pocket, which are the devices. Everybody has a device in their pocket, and why not? That's the user's device. And if they can run the model there, they can save on a tremendous amount of cost. That's number one. Then you go on to things like equally important privacy. Sometimes you don't want the data all the way to travel to the cloud. We all know that, especially as we are getting into the world of more and more personalized experiences. I don't want to share the kind of queries that I do, or maybe my private data with anybody else. So you get to give that assurance to your user base that your data is going to be secure and safe. The third big one is connectivity. Oftentimes you have experiences, you want to hike and there's an experience you don't want. What happened suddenly? The experience went away.
Right.
You want your users to have that experience no matter whether they have internet connectivity or not. Technologies have advanced in all different spaces, including how powerful the chips are, how fast the connectivity is. Yet we see delays in our video conferencing sometimes. You see the image being stuck. Oh, for whatever reason, the nomenclature is the signal is not strong and I can't do this because the
Right,
signal.
right. 4 bars, 3 bars.
Correct. And that is not a problem if the model is on the device. It's too close to you. You're doing things directly with the device, which is in your hands, and hence very fast. So some experiences require that blazing fast experience. And that's really what has brought this purpose of doing AI on the device. And we are realizing and finding more and more applications every day now.
It sounds very much analogous to something that I see a lot in our community and other communities, which is folks wanting to run models on their laptops, like using Olama and similar types of tools to let you run locally. But that, I've got Olama running on this laptop here. I like know how to pull a model down. Like I'm not sure I would even know where to start if I wanted to try to get something running on my iPhone, for example, or if I wanted to get something running on my local device.
Yeah, you're absolutely right. I'll segue into, AI Hub and slowly start talking about that. The main thing is now there are AI experiences happening all around us. And we see that because we see a Roomba in our house who's figured out how to navigate to all the spaces. We see it every day and it might not cross our minds, but that's running AI. That's running some powerful AI. There are, delivery services with little delivery robots. That's running AI. So it's become commonplace. Yet we are not at a point where every developer, let alone developer, anybody can do AI on the device. How can we get there? Because that to us is going to be a moment where we will explore the kind of experiences that we can imagine, right? Right now we are restricted by a few, semi-advanced developers who are doing this. But how can we get this in the hands of the masses? So we can build experiences which we can't even think about. That's the idea behind AI Hub, that the core challenge that we are trying to solve is what you mentioned just now. I don't know where to begin. And this is, your statement is very true. It even comes from the most experienced developers. I hear it all the time. Where do I even start?
So we've got these developers, they're seeing cost, privacy, and other drivers as reasons to move their models to the device. Like me, perhaps they have no idea where to begin. One of the things that you mentioned in there in talking about the motivation to run on devices that is blazing fast. When I think about these gigantic foundation models and running on device, it doesn't jump out at me that that would be a blazing fast experience. Close that loop for us before we transition to some of the ways you're enabling developers.
The correlation of how fast something can be is, directly related to how powerful the SoC is. That's one, and memory.
And you
Interesting.
said SoC, system on chip,
Yeah.
the chip
The
that's running the models.
That's right. So what's happening now, interestingly, is we are starting to figure out how to get these large models, compress them, so the size is smaller, so that they can run on the devices. The chips on the devices are extremely powerful. They can actually execute really, really fast if you get the model to them. But the memory is where we are getting stuck. So as the world has advanced, as technologies have advanced, we have made advancement in a couple of spaces. Now we hit memory. So when you run a llama model, time to first token becomes very, very important. And you'll see that, once the first token is generated, it's in a record of, tens and 20s tokens, depending on Snapdragon, where we are running, Snapdragon X Elite, where we are running this model. You can see that on a laptop, this experience of running a llama is much, much more powerful and seamless. Same as Copilot. Copilot runs on the device and it's really beautiful. But taking that and going to mobile brings constraint. You can't do the same. Mobile immediately becomes memory bound, and you cannot have that same seamless experience. You get throttled, you get stopped in building an experience to run that token, produce the next token, and run it fast. That's where we are hitting issues. However, there are techniques that are being used with quantization, with compression, with how we are kind of stitching various parts. You take this model, large llama model, you actually break it into 4 parts. You run one part after the other consecutively and you stitch them together. And there are lots of techniques that are happening now of how to seamlessly stitch them together and bring them together with powerful SDKs where software can take the burden and do some smart things on the devices to make this experience faster. Like you said, that's one of the pain points that everybody seems to be hitting. There's work going on. This is fairly new to us, right? ChatGPT is just about happened. So now we are getting into a mode where how can we do more? How can we do it faster? How can we bring large models? We are kind of entering that phase now.
And I'll refer listeners to some of the conversations I've had with your colleagues on the research side about the various quantization methods and compression, and quite a few conversations that I've had about some of the things that folks are doing to enable these models to kind of fit and operate well on devices from a research perspective. But kind of getting back to the issues that a developer needs to think through. You mentioned SoC. We're used to hearing about CPUs and GPUs. Now you're talking about SoCs and neural processors. Like, what's the lay of the land from an on-device hardware perspective?
A really good question. I think this is where most developers hit the biggest pain points, which is understanding what are the processors that are available on the hardware and how to best utilize them to run my model. What's happened even more is we've introduced AI chips. And these AI chips are, they do some powerful math really, really fast, matrix multiplication, processing of tensors. They are specialized to do just that. Their whole job is to take an AI workload and execute that workload extremely fast. But as a developer, when I'm trying to run my model on a variety of devices, I have no idea which device has a neural engine, this special chip, like you said, because it also was introduced a couple of years ago. It's not been there forever, like a CPU and GPU that we are more familiar with. So as a developer, I don't know which devices have it, which devices have the first generation of this special chip, which devices have the second generation. And with each generation, the chip has had more features. It has become more powerful. And I'm talking about not just about Qualcomm, generically around the globe, in all devices, this is true. Because we started with, the first version where we understood what kind of ML we should execute on the first version of chip. And then the algorithms evolved. So we have 2 plates that are constantly evolving. One is the algorithm plate and the other is the hardware plate. Both are constantly moving and evolving. And the developers are stuck in trying to understand what works on what. And that's the part where, if you look at the entire stack of how a developer goes from taking a model, which they build in PyTorch, to getting it running on the device, there are a variety of steps that they have to go through, which are not necessarily solved for or streamlined universally. So they have to learn a few things to actually take a model and get it running on the device. And that's the biggest pain point for anybody who's wanting to do this.
What are some of those things that they have to learn?
So let's take an example of an app developer who's trying to do this on mobile. And like I said, we spoke to 100 developers. So let's take, there's a photo editing. Let's say somebody is building a photo editing app and decides to put a model in a photo editing app. For this developer, the model has to go within the app, which runs on phones, which runs on tablets, which runs on laptops. And let's say if there's some other proprietary device for namesake. They have to run this on not just these devices, but generations of these devices, because some of their users will have older laptops, some will have newer laptops, some will have newer phones, older tablets. Then they have to care about what OS is running on these devices. So the phones will run Android, most likely. The laptops will run Windows. Proprietary devices might run Linux. So now their model has to run with their application. Then the question comes up, okay, cool. If I want to run a model on Android, what is the framework that I should use on the device, which actually takes this input of the model and then I executes it on the AI processor. So now they run into, should I use ONNX? Should I use TFLite? Should I use something proprietary from the manufacturer of the chip? Let's say they finalize and they say, okay, for Android, I'll use TFLite. For Windows, I'll use ONNX. And for the Linux, I'll use something proprietary. Great, they've finalized this. They then run into a problem of, I have to take my PyTorch model and get it into a format, convert it, compile it to a format which this runtime on the device, the TF-Lite or the ONNX, consumes. How do I convert it? What do I use? As I'm saying this, you can imagine that their testing surface is increasing rapidly. With every word I introduce, it's like combinations, right? And then in the end, they have to make sure that everything gets compiled, optimized to the point that the model runs on that AI chip on the device. That's the other challenge. All of these steps that I mentioned are learning for the developers. They have to figure it out, each one at a time. And across, you can see the explosion. As you think of the testing, it's an explosion of combinations that they have to go through.
When you talk about the neural processors or neural engines, you described it as a module that's really good at matrix math. That's kind of what I think of as a GPU. Does the developer need to know which calculations to put on a GPU, which calculations to run in a neural engine? Or, I would think that, I don't know if we're there today, but at some point we just want software and APIs. Maybe it's PyTorch or maybe it's another layer to figure all that out for us and optimize. Are we there yet?
We are to some extent. So these runtimes that I talked about, whether it's ONNX or DML or TF-Lite or even some proprietary runtime, they do a good job of it. However, as you get into advanced applications, gaming, for instance, or heavy, large video processing AI experience, if you're building a random thought, a film kind of editing processing you're doing along with AI, at that point you actually have to think very carefully about where does the processing workload go and where does the AI workload go. And you have to get into a little bit of more advanced work where you say that, hey, you know what, I want you not to touch the CPU or the GPU at all. When you have an AI workload, run it on the AI chip. Don't touch my GPU, don't touch my CPU, because there's heavy processing of a video that's happening or some sort of graphic workload is going on. So don't disturb that. Otherwise, my experience will be completely disturbed. So there is a little bit of advanced work there that exists, especially for certain use cases. For most use cases, we've gotten to a point where the runtimes do a pretty reasonable job, pretty good job. I'll caveat that it works well only when the chip manufacturers also partner very well with these runtimes. So that's one of the key things to keep in mind, that what the AI chip can do is very well known to the manufacturer of the chip. They know exactly what kind of math can execute. And they have to build those APIs, those integrations with the runtimes to say, hey, runtime, when you tell me execute this workload, I will 100% guarantee and execute that workload. And here are the kinds of workloads, to make it very, very layman. Here are the kinds of workloads you can send me. Here are the kind of operators you can send me, and I'll take care of that. So it's a dialogue between these two. The community runtime, I call them community because generally contributed by the world. ONNX gets TFLite, there's contribution from the world. The community runtimes and the manufacturer of the chip need to have a dialogue constantly and to keep pace with this technology. You get new and new algorithms coming in every day, so they have to kind of stay in sync.
Now, in one of our prior conversations, you mentioned that one of the dynamics that you see playing out in this ecosystem and why we're not further along is that there's no like single organization that's really driving things forward for, AI kind of pan device. Can you elaborate on that take?
Absolutely, Sam. There are so many choices. As I mentioned this, you could, any listener of this podcast will think, yeah, I heard about ONNX and TFLite, and there is DirectML, and there is all of these choices. Each of these choices have come from a different origin. A couple of years ago, there used to be Keras and Cafe and so many other things, right? We heard about. And TensorFlow was also a big one. TensorFlow is still very, very popular in terms of training in a lot of spaces. But the world started converging towards PyTorch. And this is from my at least personal learning and observation and being in the field. PyTorch became more and more dominant because of the ease of use. Maybe community gathered around it, and now you had PyTorch. And when you went to Android, your runtime was TFLite, which was built by Google, and still is contributed heavily by Google. A fantastic runtime, but you have a dialogue of Meta starting of PyTorch and the community taking over, Google starting TFLite and the community taking over, and these two have to have a dialogue. Similarly, on the Windows side, ONNX came about, which was Microsoft's community offering, and people contributed. And as world changed, as things evolved, and each one of these owners of these, or the ones who came up with these concepts, as they evolved, they went on to producing devices which were focused on, Surface came about, Pixel came about. So now your attention got, how do I make Surface experiences better or Pixel experiences better? So it just diverged a little bit, and the burden of it fell on the community. And every time when the burden falls on community, a lot of choices come about. And that's what has happened in the on-device AI world. Someone who really likes TFLite is going to contribute and take that and take a dependency and contribute and build more and more. But someone else is going to go after ONNX and build more and more. That is what has happened. So there hasn't been what is the one thing? Why isn't there one solution on every device? There isn't one solution on every device. And we are going to constantly see that for the near future, at least for a while.
You mentioned all these steps that a developer, not really steps, but you mentioned all of these things that a developer needs to think about as they kind of phase through the process of getting their models on the device. At some point, they've got something that's like kind of working. I think broadly in the industry, maturing from a testing and evaluation perspective, how do folks need to think about testing and evaluation in this very fragmented world that you described?
That's a very good question. It's also a very hard question because as the devices are exploding, as there are more and more generations of chips coming with powerful functionality, you'll always have to think about the old and the new until the old phases out slowly. So a developer has to care about how do I test across all of these variety of combination of devices, OSs, runtimes. Now, how do I make sure that my model that I had for the previous generation of phones works for this generation and the next that's coming out? And they'll have to constantly care about that. And we have to, from Qualcomm's point of view, we think about this very, very carefully and hard because that is one key point for developers to adopt on-device AI. The more we make it easier for them and the more we guarantee that the experience are going to work consistently no matter which hardware, the more we'll see people exploring and expanding their journey into on-device AI. Today, it's a burden on them. Really, people have to set up a rack of hardware devices in their office or something to test this. And it's a very tough problem. There's no way around it as well. To some extent, you can say, okay, I'll have virtual machines and I'll test on virtual machines, which are form factor kind of similar. But at some point, you do have to test it on real devices. And that's where most developers struggle today because it's costly. It takes a lot of time. There's a lot of work that needs to be put into to guarantee that the model works on the device.
That's also where AI Hub comes in. We met at an event recently, and I had an opportunity to hear you talk about what you're doing with that. And one of the things that struck me as super interesting is this idea that through this AI Hub, developers can get access to actual physical devices that they can test their models on. And it really made me think about, back in the days of kind of early, I don't know how early web, but like, when we were developing web pages, because of all the incompatibilities in browsers, you would, sign up for these browser test websites and you would give it a URL and it would like fire up VMs and give you screenshots of your web page running on various different types of browsers. I don't think we're doing that as much anymore. I guess maybe if you're a huge commercial app, you're maybe doing that. We also did that with like email clients back in the day before, when that was very unstable. I remember like testing an email to see what it would look like on different devices, and haven't done that in a really long time. But what you described made me think about those kinds of experiences. And to your point, when you're at the point in time where the world is like very fragmented and confused, and you've got a lot of different things that you have to design and develop for, like you need that kind of functionality. And, I don't know if this would be good for you, but hopefully as developers, we don't always need this and you'll provide value other ways. But at least right now, I can definitely see how someone trying to navigate this world might need that. So that all being a bit of a segue, can you tell us a little bit about AI Hub and like what you're trying to do with that?
The thought of AI Hub came about when we launched this little startup. We were thinking, why is it so hard? Like AI is everywhere. Like you said, we see more and more people building it, but we still see people being hesitant. We spoke to 100 developers, and every single one of them was talking about, oh, I have to have a rack of devices. This is hard. The testing is hard. Even figuring out whether the model will run on the device or not is hard. And I have to take out time from my development and do this, which again is a burden. A cloud setup is fairly streamlined. I can go keep that. This needs to change. We need to make it more and more accessible. That is where this thought of AI Hub came about. What if, and it was a very simple problem statement. What if, as a developer, I could come with a PyTorch model, just a trained model in PyTorch, and I say that this is my model. I know nothing about devices. The statement that you made, I have no idea what it means to run AI on the device. But I'm going to upload this model to your service, and I'm going to tell you which devices I would like to run this model in. Can you give me an answer whether this model runs? And if it runs, how well does it run on the device? That was the initial thought and idea behind foundational principle of AI Hub. And that's what AI Hub does. A developer comes in, they upload a PyTorch model. They say that, hey, I want to run it on Samsung 24, 23, 22 devices, from laptops to phones, to tablets, to drones, you name it. And we will take that model, we will get it, the platform will under the hood get it compiled and converted to the format that is going to be accepted by the device. Use the appropriate runtime. If you don't know about a runtime, we'll make the recommendation. We'll pick the right one for you. And we'll pick the one which will guarantee you the best performance and accuracy on the device. And we'll give you an answer within 5 lines of code and 5 minutes, whether A, the model works on the device or not. So it'll give you an answer saying, hey, this model works. You can bring this experience on the device. And if it does, it'll tell you how fast it is, how accurate it is. So your journey can go much, much more smoother. Your decision of moving from I'm thinking of doing on-device AI to I'm doing it on-device AI is sort of in a second. That's what we are going towards. And we hope people are going to build many, many beautiful experiences and surprise us with AI on device.
I guess I'm wanting you to kind of characterize this experience that we talked about of, things being very different from one to another. Are you seeing a convergence, and are the things that someone needed to worry about 6 months ago the same things that they're worrying about today, and the same things you expect them to worry about in another 6 months? Or like, how are those sands shifting?
Things are definitely converging. Today, if you think about vision models, these vision models, the operators within the vision models, the mathematics within the vision models is fairly understood by almost all devices today. because we have seen a lot of use cases in that direction. And we have made the community runtimes, their integration with the chips has been really, really, from a software perspective, from an hardware perspective, it's very robust. So anybody starting with vision today is an easier journey for them. But this is where ML is going to always surprise that it doesn't stop innovating. It is constantly coming up with new things. So here we are, we were like, oh, finally, vision is solved. You can now take a photo and edit it. And we are on to, can we do things like crazy LLMs, which has vision and audio and some language and editing? Tell me what more I can pack together. So we are going to always be in an innovative phase with ML, and that's a good thing. I think that makes it super exciting for all the pieces involved, from the silicon manufacturers to the software builders along the way. It's a very, very exciting time for all of us.
When you think about the types of models and model architectures that a developer might want to put on the device, I'm imagining a spectrum, as you alluded to just now, from, tried and true to kind of bleeding edge, just read about it in a paper and, wrote the code myself to implement it. Can you talk about both from the perspective of the underlying hardware, the neural engines and, framework software and the, AI hub or testing infrastructure? Like, do I need to wait for cutting edge to be supported, or, do all of these layers have the ability for me to kind of roll my own when I need it? Like, is it, I don't know if batteries included, not required, or whatever the right analogy is here, works for this, but, how much flexibility does a developer have to implement things on the cutting edge, or are they kind of trapped behind some abstractions and need to wait for the lower levels to evolve for them?
That's a very, very good question. I'm sure many developers have the same question. To some extent, there's flexibility. So I'll give you a very simple example of somebody came up with phenomenal algorithm for languages or for audio to text translation or something like that. And there's an operator, it's really a mathematical equation. They've packed it in this one single operator, which is brand new. And they introduced it in PyTorch because they can come up with a brand new operator. Now, everybody along the way doesn't know about this operator. So when it comes down to the runtime goes, oops, what is this? This is new. And this happens today. This is not future thing. This is happening today. What you can, of course, the runtime has to introduce it. It then goes down to the chip, to the SDK and the chip. And the chip also, the SDK has to tell the chip, this maps to, these equations on your side or kernels on your side. They both also need to have a dialogue. And for them too, this is a surprise. Whoa, what is this? This is a new operator. Today, what most developers do, they can deconstruct this operator into what is known to all of these pieces. The flip side of that is, if you deconstruct, you pay some price there. Either the speed will be impacted or power will be impacted. There is a trade-off. There's a price to pay until it's natively supported all through. And this native support can be, hey, the silicon itself has to evolve, or the software that is communicating with the silicon has to evolve. Something has to evolve, and we have to wait a little bit sometimes. The good news is most of the advanced algorithms are doing exactly this today because they know that the software will evolve. If it's within the control of software, it's a cycle of release of 2 months, maybe even 10 days sometimes, but they know software can evolve. If the silicon has to evolve, they can actually point the silicon in that direction and say that, hey, this is the next magical experience coming down the pipe. That's where we have to go. So it's a good thing to have a little bit futuristic, but having the ability to do it today, like you said, can I still experience that this is possible? That throughout the AI stack is available today for most of the developers, and they do that often.
You mentioned power in there, and that's something that's clearly important for folks that are running on device. You wouldn't want your app to drain your users' batteries too quickly. We talked a little bit about kind of testing and evaluation via AI Hub. What are the kinds of metrics that are testable or measurable when you're operating in the environment? I'm imagining, you mentioned like just working, like does the thing work or does it not? So accuracy and correctness, presumably some measures of performance, maybe latency, power is that one of them? Can you talk about the various metrics and the way you see developers trading these things off as they're trying to build experiences?
What the developers see today are following metrics. What's the first app load time? How long does it take for first token if it's a LLM? How long does an inferencing for a certain number of samples take? So I can, do some sort of a load test to some extent. So time to inference, accuracy, how accurate is it? If I give you a sample, can you give me what accuracy you see? Do you detect if I'm doing detection? Do you detect that? Those are important. Power is one metric we do not show today. It's very case by case. We work very closely, and the reason we are doing that is because we want to actually build that feature really, really thoughtfully. Power is measured in a whole bunch of different ways where you need to have a certain setup for the device, a cold environment, a warm environment. You actually have to have a lab which does replicate real life temperatures as well. There are external temperatures. You might find this fascinating, but there are external temperatures that we have to create as well. You need to have a stable setup to do that, and then you have to measure the power while 5 apps are running. What happens?
So, in other words, yeah, unlike some of the other metrics that you described, power has a bunch of externalities that don't necessarily lend themselves to just running your model in a device farm because of sounds like noisy neighbor or other things running on the device, power, etc.
That's right. You need to keep in mind some external factors as well as internal factors to the device as you do power measurement.
Are there like proxies for power? Like is performance or like CPU utilization or NPU utilization a decent enough proxy for performance that it will get you to a model at the door?
That is a really good question, and that is accurate as well. Where in the absence of having true power metrics, that's what developers look for. When my app is running, when my model is running, how much is the GPU, CPU utilization? Where is it going? How free is the AI chip? How much is, and that is why moving the workload to AI processor is what everybody wants. Literally, everybody wants that AI processors are designed to be extremely power efficient, so everyone is looking for, why is that one operator getting dispatched to the CPU? I need to do something about it. I need to move the full workload onto the AI chip. That is the proxy they use in the absence.
Yeah, I'll say that I don't think I really got that until I saw some of the demos at the AI day that I referenced earlier. These were demos in particular of the laptop devices. I forget, are they Copilot devices or
Snapdragon X Elite, yeah,
the
Copilot device.
Snapdragon Copilot laptop devices? There were a number of demos of like, really heavy duty inference. And you could see that on these devices, it was pinning the NPU, but your CPU and GPU were not affected, and you can continue doing your work. That made it like viscerally real for me because I know when I'm doing like heavy duty processing, you can kind of tank your device and you can't continue working. But with those workloads shifted to these dedicated units that don't get in the way of your everyday compute, it not only allows them to perform much better, but for heavy duty inference does not interfere with the usability of the device. It was kind of eye opening for me in that regard.
It's fascinating, isn't it, Sam, that now when we use, I don't know if you've experienced this lately, probably never, when you kind of use your mouse and it's laggy or slow or the window doesn't go, it's so unacceptable now. But that,
Oh
what
yeah.
you described, is the reason why it's unacceptable because we have done such a good job with these processors, leaving, the processors free to do the right thing and not disappoint the user. And that has become very important for all the developers that I don't want to, that's the death of any machine or any application that, oh, it's so slow, it just doesn't open.
So our conversation thus far has focused on mobile devices, smartphones, laptops to some degree. But you and Qualcomm more broadly also do a lot of work in IoT and autonomous vehicles and other kind of specific fit to purpose types of devices. Can you talk a little bit about the degree to which do all these principles apply equally? Or are there specific things that IoT developers need to worry about, that AV developers need to worry about?
These segments are so different, Sam, that I'm glad you asked this question. IoT is, when you think of IoT, some people even ask me, what is IoT? Like, Internet of Things, what is that?
What does that mean?
So truly we have clubbed, everything that's not mobile, not tablet, not laptops is IoT. It's kind of, we've done that in some sense. But IoT has some interesting challenges. The good news is most of when people are using IoT, building for IoT, they typically control the entire experience and the entire, right from the OS to what goes into the device, all through and through. And you think of a drone, right? The drone is going to have the OS you decide, all the bells and whistles that you decide, the software you decide, the SDK you decide, the runtime you decide. So it's in some sense end to end, it offers end to end control. The flip side of this is some of the IoT devices might be really, really tiny. So you get into this world of one time use devices, a couple of time use devices. And now you want to, on top of that, run AI on these devices. The biggest challenge there is how do we continue to expand the longevity of these devices, which are already as is tiny, small, cheap. How do we build chips for these that are actually long lived and powerful to run AI? The overall principles of how I get a model and how I get it running remains the same. The challenges remain the same, but the form factor has suddenly changed, and hence the kind of workloads you can run on these devices definitely change. In contrast, a car is a ginormous computer. So everybody is super happy about that because finally we can have a large computer sitting in here. Yay, now you can talk about AI on device is sort of what comes to mind to many, many people. So there you go into experiences in ADAS, voice detection, everything that's going on with autonomous. It's a huge machine that gives you a lot you can do, but at the same time there is a lot that needs to run right there, not just AI, but you have so many sensors, and they're constantly collecting data, and somebody has to be processing that data, and then you will take decisions on that data. That itself is a ginormous task. Even if there is this large computer, you can imagine multiple computers, they're doing many, many things to keep you safe in the car for self-driving. So those are the two form factors. Intelligent, very, very interesting and intelligent use cases are of the one I have come across is a drone that's sent into a mine before a human goes in so that it can map out a mine. And it does use a lot of AI. And there you have a constraint of the drone having no connectivity as well as limited power. So it has to do its entire job, come back to the docking station and charge itself, just like our Roomba. We get disappointed to see Roomba lying around not charging. That drone would go through that. So that's, I think, mainly the form factors are different, the capacities are different, but the software principles remain exactly the same, which is good news for us because you can replicate from what we have learned in the mobile and the laptop worlds, the tablet worlds, and bring them into these worlds.
So along those lines, maybe setting aside AV, the use cases that are most apparent for IoT tend to be vision oriented. Have you come across interesting ones for LLMs?
There are few, very, very few that are cropping up now. And the reason, like I said, I think the reason we call them IoT use cases because everything that you don't put in these segments, you put in IoT, you don't put in
It's
mobile.
kind of
And
a slush bucket of
correct. So now you have a kiosk, and on the kiosk you have face detection because Sam goes to that kiosk every day and gets a power bar, and the kiosk has learned when Sam comes in 10 o'clock, power bar.
what if Sam wants to talk to the kiosk and tell it what he wants? And so that's a use case.
That's where it's evolving now, and you will see some of these use cases appear, different form factor, but we are seeing some LLM use cases slowly appear in the IoT world as well. We're at such an interesting time. Every space is evolving. That's why I think there's this general phenomenon where even when we from Qualcomm go on to talk to customers, the first question is, and how do I use AI in this? Like everyone's asking that. So it's every use case is evolving. Everywhere there is going to be more and more things done to save our time. It mainly comes from a place of how do we give back time to humans so they do something better, bigger, and they don't have to do this rote thing. You don't have to put in a bill and punch the numbers and get that power bar out. You can just talk to it, talk to the kiosk, be blazing fast.
So in a world or an environment where everything's changing so quickly, Do you have a sense for what the future holds?
To me, that's going to be that's something I'm really, really looking forward to seeing. What is going to be the next wave? We have seen the wave of AI come, and everybody's talking about AI is here. What we see next is I think feels like a sci-fi movie. That's what I imagine is going to happen. Slowly, we will, and I still don't have a robot who can fold laundry, and boy, I want one. Like, really. That's one. So I think the world
I
is
saw
starting.
one at CES a few years ago. It didn't work very well.
Yeah, a good working one, which actually does the job. But I anticipate more advances in silicon is going to happen, more advances in software stack is going to happen, and we're going to reach a point where we see just so many use cases that are up and coming in the AI field.
Well, Siddhika, thanks so much for taking the time to chat about on-device AI and the work you're doing to support that.
Thank you. This is fun.
Thanks so much.